All right, thank you for coming. It's 2 p.m. We'll be started. My name is Stéphane Reynaud. I'll be presenting today. All right, so we'll be talking about SciTools Understand, mostly what's new in the version 7.1. Again, my name is Stéphane Reynaud, and I'm the engineer that does all the demo in North America. So today, what I want to do is discuss Understand 7.1 and actually show how it goes beyond what we consider the standard static code analysis, which usually is used to enforce things such as MISRA, CERT, AutoSAR. And so we will be taking the role of a developer who has been in charge of dealing with SFML. That's an example project that we picked. It's a small multimedia library. You can find it, it's open source. Nothing much to that project except it's in C++. And I wanted to use that as a demonstration. So what we will do, we will look at CodeCheck, which is the traditional static code analysis in Understand. We will visit a new extension of CodeCheck, which is Bug Hunter, and I'll explain what that does. We will review AI generation in SciTools Understand. I think a lot of people probably want to hear about this. What does that do? How does that help? We'll show virtual debugging, which is a capability that was added. And I'll review dependencies as well in Understand, which is the something that's sometimes misunderstood, and I think it's really important because it will help you resolve development problems or actually be more sure about your development. And finally, we'll talk a little bit about plugins and customization and Understand there is many things to be done there. So as a first step, just as a refresher, actually there is a lot of things that have been added to Understand, and I want to show that to you guys. We will actually run MISRA on SFML and see a little bit what has been added, what is new into CodeCheck. So for this, we will, oops, hold on. Oops, no. I'll do this. Okay, that doesn't seem to be working. Okay, so let's open Understand and let's see how we can use CodeCheck to run MISRA on Understand first. So again, if you're familiar with SciTools Understand, you'll recognize the GUI. You'll recognize all our project files that we have analyzed, as well as all the entities that we have found in the code, right? This is what Understand. So what I want to look first at is CodeCheck, which is the capability for Understand to run checkers. And you may not be familiar with this part of the GUI if you have used Understand for a while, because they have modified it. So the way is, if you actually want to run an inspection on some source code, you will first have to define a configuration. And this configuration, there is a new GUI here. You can select using the wrench here, which will set you the set of checks that you want to run on the code. Specifically here, I have defined a MISRA C++ 2023 demo. And if you actually look at it, it is a 2023 C++ MISRA standard, except I've removed a few checks so that we can actually run that during the demo. So you have that ability to define new configuration and to edit configuration. And what I find really attractive here now is that you have all the checks that are described, but you can also filter about what you want to use. For instance, I can say, okay, well, just show me the C++ 2023 check, and you can see those are just the 2023 check minus the one that I have not selected. And also you can filter by tag, so you can say unused, for instance. Oops, sorry. Oh, my keyboard just died. Hold on, apologies for this. Okay, bear with me for a second. Okay, so see, I can type unused here, and then I can see, for instance, all the checks that relate to, unused thing in MISRA C++ 2023. So there is a great way to actually define your taxonomy, define the rules you want to run. So this has been really improved in 7.1. Once you have defined your configuration, you will actually select it here, which is what you want to run. And the second thing which is interesting about Understand, you can limit the list of files to a subset of the files that you have on your project. For instance, you may decide not to run MISRA on your example or your test figure. So you can actually do that in Understand by selecting where you want to run your checks. And in this specific case, we are doing a MISRA validation example set, which is what I have defined for this demo. And those groups can be defined using the architecture in Understand. So I have just basically decided to run this check on those examples. So I can select a specific set of files on which I run the inspection. In this case, we will run the inspection. And what you will notice is that, again, the GUI in 7.1 have changed for this. And you are going to get a line item here per run that you execute for that specific check. So it's going to take a little bit of time, but we are running the configuration. So now what you will have is you'll have the ability to go and have different views by which you can actually see the result. You can, of course, see the violation, all the different violations in the code. But you can also view the result by check, which tell you like every check and how many violations you have for each of the check. You can do same thing, a list of violations by file, which was already present in the tool, but this is done a little bit differently now. But two things that are quite new, especially if you are in this domain, is that you do have now a compliance report, which will let you create a PDF with a summary of what was done, with the coverage that was enabled, the set of violation, as well as the ignore. Of course, we don't have any ignore at the moment, but you can generate this report, which can be delivered in an HTML format like this, but you can also export this report to a PDF file if you wanted. So there is the idea of creating compliance report in Understand now. And they are fully customizable if you use the Python API. So there is ways to fully customize those things. I will not go through this, but no, it is there. The second thing, which is that not many people know, close those things, is that if you go and you now have a little eye here, and the eye is interesting because when you actually click on that eye, see if I unclick and click, you will be able to see in the code the different violation. So you do see the violation directly in the code, which is something that has been added, and it's actually quite powerful. So, so you can see those violations in the code. Lastly, when you have run an inspection, you can set it up as a baseline, meaning that every single one of the errors that have been detected will actually be ignored for the next run. So I will set this up as a baseline, and you can see that now my demo MISRA C++ 2023 has been baseline. So this is like the traditional static code analysis, right? This is the traditional ways of looking and running potentially a MISRA on your code. But as developer, we have tasks that are different than just running this, right? And the question is, well, how is Understand going to help me as a developer to deal with my task, my everyday task? And for this, we have created a little example where we'll become a developer, and we just got a message from our test department. And we did not get it by email. And to illustrate another functionality and Understand, we have actually the message in our annotation. I don't know if you have used annotation in Understand, but there's a way you can get a message or specific comment outside of the code for the code. And specifically here in our annotation, we have the test team left off a message. They said, hey, we believe this is responsible for a memory leak. Please investigate. So they mapped that command to that variable extension, and they are assuming that there is a memory leak here. So what can Understand do to help us with this. By the way, the annotation, when you have a little message like that, they are actually stored into a JSON file that is part of your project and that you can easily share across team. So first thing we'll do, and I think like there's something in Understand which, this is like the best of Understand. It's really that view information. So for extension here, I can go and look at where is first, extension used, because now someone suspects there is a memory leak here. So, but where is it used? And I can see that all the reference which is all the place where extension, everything is happening in vulkan.cpp. So obviously my problem must be happening here. And so I'm going to be in charge of finding potential memory leak in extension in vulkan.cpp. So, and that's where SciTools have added in Understand 7.1 a new feature which is called Bug Hunter. And Bug Hunter is an extension of the static code analysis as I just showed you, except it is based on the CLang or the Clang ASTs, which is the abstract syntax tree, right, created by the CLang compiler when the file are analyzed. And that lets you actually find more dynamic bug in your project. So let me illustrate this. In order to do this, we will go back to CodeCheck. And in the configuration here, you will see that there is now Bug Hunter that was added. And then you'll find all the usual culprit of all the problem you may have with code, right? Division by zero, memory leak, all those things. And so Understand we'll be able to check on those, and I'm going to show you how it does this. So for demo sake today, because I wanted the analysis to run in a limited time, I have created something, a configuration when I'm just running a dangling pointer on it. And I've created that configuration. So that's what we'll be running. We'll be running the demo memory leak. And we know that it's potentially happening in vulkan.cpp. So same thing, I have actually created an architecture to limit my analysis on vulkan.cpp and vulkan.h. So let's inspect this. And as you can see, you do have a different line for the execution here. And we did find one violation with that new check, which is happening here at line 2644. So we do have a memory leak happening here. But one thing interesting about CodeCheck, which a static code analysis doesn't do, is that if I actually highlight this, now my memory leak shows the same way here as a hint in the code, except that hint is purple because it has a specific property, which is it allows me to explore the path of executions that led to that memory leak. So I'm finishing here where my memory leak has happened, but I can trace back into all the different locations in the different loop, all the way to where my memory was allocated, and also how I actually managed to get there. So this is a pretty good insight on a bug, but also the execution path that have created that bug. So, and that's specific to Bug Hunter. So, now, I mean, I'm facing this bug, right? So the question is, I need help. And how does Understand? Understand help you find problems, help you identify problems, but how is it going to help you with common question you may have when you are facing one of those difficulties? When as a developer, I'm actually looking for or having specific problem, I will first want to understand the global picture, right? Where am I in the code? Where do I fit? Who's getting involved? All those things, right? Having a global idea of what am I touching, what I'm dealing with. The second thing is I'll probably go and look for documentation if it exists, right? And the problem is most of the time, documentation doesn't exist. I will also have to understand the control flow, what is executed, how do things run, how do I get here? Well, we got a little bit of a hint from Bug Hunter, but maybe there is other things we'll need to understand. And while control flow, the execution path is interesting when you look at code, another thing which is really interesting to look is the data flow, which is, hey, I have that variable. Where does its value may come from, or where does it come from? What affects the value of that variable, right? Those are questions that we may actually have to answer when we're trying to debug these things. And then when we start touching at things, we need to be aware of the impact of what we are doing, which is, hey, who am I going to impact? Who is impacted by me? All of those things, so you need to be careful. So I'm going to try to illustrate in the next, half hour or like 20 minutes, how Understand can help you with every single one of those questions. So let's start with the global concept. I mean, we do know now that we have, close and do a little bit of house cleaning here. We do know that we have a problem here, and everything is happening in vulkan.cpp. But where is vulkan.cpp? What does it do, right? Let's just have a macro view of the project. And I will try to do a macro view of project with Understand. I usually use two things. The one I use is a metric tree map or matrix, right? Because Understand can do a lot of metrics. And when you generate this, this will generate a heat map or a tree map, depending on what you want to call it. In this specific example, I have set up the size of the square as the size of the file, and the color is linked to the complexity of the file. So just to give me an idea of how vulkan.cpp and vulkan.h are fitting in my whole program, right, which is the first thing I want to look at, what I can see, those are fairly big files, right? And they are in the example directory. They are not too complex. So that gives me a sense of where vulkan.cpp plays. The second thing I like to do in order to understand where vulkan.cpp is usually use the dependency graph. And the dependency graph show me, if you want, how everything relate in the code. And we will go in more details about this a little bit later, but that gives me a graph here which I can interact with. So I can look, and my code is in vulkan.cpp, which is here. So I'm interested in this. I am not interested. So if I use the control key, I can actually select things. I can hide those guys because I'm not interested by those guys. Oops, did I think I unhide everything. So I'm just gonna redo this. Oh. Because of course I want to keep my Vulkan. I can open source, I can open this, I can actually say, okay, show me the children or the relationship in this. And now, again, maybe today that's not actually really demonstrative for us, but we can actually see how vulkan.cpp, what it relies on. Well, it's going to rely on graphics, it's going to rely on Windows, but it's not really relying on audio, it's not relying on network, and it's not directly relying on systems. So those are information that could be real, important in my bug later on. But in order to get a sense of where a file fit in the big picture, again, that's a great tool to have. So now the next question is, after I have a sense of what my project look like, I start getting a sense or a feel for what my project is. Where is the documentation? How can I find the documentation? So if I specifically go about extension, or glad VK extension value, where can I find information? Well, it's somewhere, or I can go talk to someone. What SciTools have done, and I think this is, to be honest, this is becoming one of the priority at the company. This is something that is really taking a lot of importance in the path of what SciTools Understand may become. But Understand have added a LLM, a large language model, locally on the machine. So I know a lot of people that work and use Understand are in closed network, closed area, knows that all what we have done here is adding it locally to the machine. Nothing goes on the internet, nothing gets sent. And understand I've created the AI, AI documentation, AI generated documentation that is called AI overview. And so all the text that you will see in here is generated by that local language model, right? Which is actually a Llama model. And it will create an overview of the different items that you can click on. So if I click on this, I get an overview of that function. If I click on extension, I get an overview of the extension. But it also provides you some maintenance hint about what you need to be careful with extension. And of course, he said, well, there's memory allocation, outdated memory management, potential memory leak, right? It gives you the risk. Well, the risk is, of course, all the risk we have with a memory allocation here, and as well as usage. So if you actually go click on GladVK filing extension, it actually find, or try to define documentation on how to use something. So for every single item in the code, you can get an AI overview or AI usage on what that element is. So a few questions, right, would be like, well, how long does it take? So I do have a GPU on that machine. So hold on. I don't exactly know. Okay, maybe I do this. Okay. Maybe that's not the best example. Hold on. And there is a refresh button, but it is, for some reason, I don't. Anyway, so the point is, it's going to take some time to generate things, because one of the key thing about this feature is that it's not a simple prompt, right? Understand the tool is actually using some of the data it knows about something, such as the structure, with calling, all those things, and it actually inject a prompt which is really smart, and that's where actually the secret sauce is, if you want. He inject that in the LLM, and then it will create the documentation. You can do that if you have a GPU on your machine. You can actually do it locally. But if you don't have a GPU, you can run this UND AI prompt maintenance, prompt overview, prompt risk, prompt usage. So you can actually have a machine that will overnight run and create all that documentation for you. And then the next morning, you will get a JSON file similar to the annotation I talked earlier, and you will be able to put that on everybody's project so that that documentation will be there even if your machine doesn't have a GPU. And the results are actually really satisfying in terms of the information that Understand is able to generate and to create. I know a lot of people will have questions about this, so it is one place I suggest you go find some answer. If you go to support.scitools.com, right, support.scitools.com, and you look for AI in the search, you will have the Understand AI page here, which is quite valuable, and there is all the information you need to know about running, specification, what does it take, all those things, right? And also how to turn it off if your machine has a small GPU and it takes too much time. I mean, one of the easy things to turn it off, you just close the AI overview window, and then it will actually close. But again, this is where we are at, and please send us feedback about if you have ideas or things you would like to see on this. As I said, this is becoming critical. We have such a great feedback from this, potentially to, like, even if you are in the process of starting a documentation of your code, this is a great tool to do. So, all right. So we were talking about having an overview, about getting the documentation that doesn't exist, that now we can generate. Now, another thing which is really important is looking at control flow, right? And the execution in the code. So I think you're all familiar with the butterfly graph, right? Which lets you know this function, where does it fit in terms of the control flow, which is where it's being called from, where it's called, or what is calling. I want to just point out that there is variant here. And you may want to look at the cluster one. The cluster one is interesting because when you use the cluster one, you can, if you right click here, you can aggregate node by, and you can say directory structure file. For instance, I can do by file. And then when I have a call tree like that, it's actually showing me the function, how does it get called, but also what file I'm going into, which gives you a lot more insight in terms of understanding where is that call tree leading you or where you are coming from, right? So really important to see this. So I do see there is a chat. Okay. All right. So this is quite important, the call tree. Not that as well, don't forget that, you know, this shows one layer of call, but if you want the call that are made from the function you call, remember you can do call def, you can increase that, so I can actually go deep down here. Now you see function pointer here actually, and then same thing for the call by def, you can actually change the thing. Know that as well, you know, you can do that on a function like this, but another thing that people have a tendency to forget is that you can actually do it on the file. So I can go and I can do a call and call by on the file itself, which now show me, you know, outside of my big file here, where am I calling, what file am I calling, and where I'm calling from. So know that you can do this as well. And here they have a variant which I really love and I find super interesting when you're trying to understand the structure of the code, is that if you switch to internal, see, I have the internal of the vulkan.cpp file, which is, you know, there is a main, it's calling into a class that then is going to call those function, and you can explore this, and you can even view like how the class is structured. So this is actually quite super interesting when you do those call tree within a class or within a file, because for documentation, this is sometimes what you want to create, right? So this has to do with call tree. Oh yeah, one last thing, and I think that's something that is just added. And again, something we will probably want to get some of your feedback if it's possible, where if you look at this function, you do have the ability to do a remote debugging on it. So there's a little button here, which is Start Virtual Debugger. And what the Virtual Debugger lets you do is really, you know, if you, how would you say to your colleague today, hey, follow this flow in this function, this is how the problem work, right? How am I going to tell Jim here, oh yeah, you have to go 4 forward, 2 left, 1 down, you know, it's just crazy. So here with Virtual Debugger, you can actually simulate your execution by going down, going in the loop, you know, going up the loop. And I can actually go and do those things. And as I do this, it's actually creating a path of what I have done. And I can copy that path to people and I can send it as a documentation or something, right? And so you have the Virtual Debugger. But again, is that a feature that's interesting to you guys? Is that something that you think you can use? Is there something that's missing that would actually make it a little bit more valuable to you? Again, feel free to send us feedback. Just a tangent, I have seen that some people are actually asking some question on the chat. I will reply at the end of the call. If you stay with us, I will reply to your question, no problem. But I will probably just follow my flow for now. So, but feel free to type question and I will address them at the end of the call. Okay, so we have looked at our vulkan.cpp, how it fit in a project. We got some documentation of our extension there that has a memory leak. We have actually looking at the control flow, how I can actually figure out how a function plays with the other. But there is another graph that a lot of people are not even aware of, which is really important, which helps with the data flow. So this extension here, right, we are actually freeing extension of I, right? We're freeing a lot of them, right? And why do we have a memory leak here? Well, what we can do with understand, there's a new graph, which I love, which is the variable tracker. And so the variable tracker is not something many people are aware of. But what it does, it shows where does a variable can get its value from. And so right now what it's showing us is just extension is set to null here. So if you actually click on extension here, you will get the entity. But if you click a little bit outside of it, you'll have go to source. And if I click go to source, it actually jump here, and it actually did jump here, and it showed me that it's null, right? So that's where extension got its value from. But extension must get its value from somewhere else, right? And you can actually see extension here is being passed to a bunch of function here. So how come that graph doesn't show it? Well, it's because I don't have that thing, assign reference enabled. But as soon as I do this, you are going to start seeing a graph, which is quite interesting. Because now you can see that extension, yes, it's getting its value from extension is equal to null. But at some point, it is passed as a reference or a pointer to something called out extension. Well, out extension, okay, where is out extension? So I can go to edit definition, and then it's going to show me, it's actually see a pointer to this thing. Oh, out extension, okay. So it is passed by reference to out extension, which itself gets its value from something else named extension, okay? And that's not the same extension, right? So if you actually look, this is the extension which is defined here, right? This is a different one. And then that extension is getting its value from, oh, an allocation here, and then sub-allocation here and sub-allocation here. And for every one of those pieces of code, I can see that this was impacted by this function, by this method, by this thing. But in this specific case, what that showed me is that extension was allocated first as a big memory, and then it seems like every single extension with an index was allocated something. So obviously here, I start having a feel for what may be going wrong, which is that, you know, my extension, while I free every single one of them, I may forget to free extension. And so this is like, actually, this is a bug, right? You forget to free extension. I mean, you don't really have to understand this, but what I want you to remember is that whenever you select a variable, you have that graph, which is a variable tracker that really lets you see the impact. And if you are going to go all the way to that variable tracker, you can actually go back to the full program. So it's actually quite a powerful thing in the sense of finding what the bug was, right? So so we have seen like variable tracker. So another thing, and again, last thing before I show you something, before we fix that bug, is that if I'm really going to try to look at something, right? If I'm going to touch and modify this function, or potentially extension here, you know, how do you determine the impact of something in the code? I think it's really relevant for many people. We have many people coming to us and says, well, you know, I want to get a good impact analysis of how, you know, my change may impact someone. And the way you do this with Understand is by using dependencies. And I want to re-explain what dependencies are and how they are visualized in Understand. So give me just a few minutes to do this. So if I actually take this function, for instance, right, I can do view dependencies. And this is my function. And my function depends on a few things, right? So that function depends on other things because of all those different things that happen in a function. For instance, I depend on other function because I call them. I depend on some variable somewhere else because I set them. So you do have external dependencies of that function. That function depends on those things. And the same way, I can go reference to, and I can see this function, really only one person is dependent on it, which is another function because it calls it. So this function this function here is dependent on our function because it does have that code here. So this is how Understand does dependencies, right? So it shows you a list of things that happen in the code which involve somebody else, and that's the impact. And a great way to look at it is that this is a list of everything that happened. But if I actually go there and I group by entity, now this guy, this function is dependent on those things, 3 objects, which is variables, and 2 function, and is depending on this function because of those things, is depending on this function because of these things, right? So I can actually see how an object or a function depend on other things in Understand. And you know what I'm explaining here, it's easier to understand on the way down than it is on the way up. But because this is a function that only one person called, the other path may not be super interesting. But think of it, this object is dependent on those guys, and I know that now. But now, how does that apply to a project in which usually I have files, right? Well, all those things are defined somewhere. And again, same thing with this, you can group by the definition file. So basically, this function is only dependent on things that are in vulkan.h, because all the entities that we have seen before, they are defined in vulkan.h. So this is the way you can see where someone depends on things, and depending on where those things are defined, this defines the list of files to which you depend on. So now if I was going to take this function, but instead of the function, I'm going to take the file, right? If I do file, view dependencies, right? So vulkan.cpp define all those things, and is dependent on a lot of things because of all those different actions that happen in the code, right? So same thing, I'm going to take vulkan.cpp, I'm going to group by entity. This is all the different elements in the code I am dependent on. And then all those elements are defined somewhere. So I can actually go and I say group by definition file. And now this is vulkan.cpp is dependent on all those files because those files define things that are related to. And similarly, you can actually go and you can go group by even the directory structure. And now I can start seeing even in my directory structure what I am dependent on. So remember when I did graph, dependency graph by directory structure at the beginning, and we did this, and then we selected Vulkan, and then let's remove what we don't need again. Oops, sorry. Remember those arrow vulkan.cpp has 13 dependents on system, 15 dependent on Windows. Those were the thing we were talking about, right? And so the same way, if you are touching system here, well, I guess test is dependent on you and vulkan.cpp is dependent on you. So this is the way you can actually do that. But I really wanted to revisit dependencies because, you know, I think we're talking like between experts here. And I think it's really important to understand that because when you're actually looking at modifying code and the code change and the code you want to change, this is where Understand becomes really, really powerful. Anyway, we'll revisit that later a little bit on. So, oh, okay. Sorry, I'm not there yet. So we have seen, you know, I've revisited the dependency browser. So now, let's say we do the fix. So, you know, we have understood that extension is, you know, like that this actually has extension here need to be freed. So we are going to add that to the code. So let's do this. So to do this, I'm going to close Understand. And then I'm going to check the new version of the code, which is a fix, right? And I think it's called demo v5 fix 2. So this is the new tag by which the fix have been implemented. So I'm going to reopen Understand here. And then we are going to reanalyze the project. So all the files have been changed, have been updated, right? with the fix. You can see there is now a free extension here, but I will recommend, if you do a Git checkout on something, to reanalyze the whole project. There could be a little bit discrepancies when you have like a full project that's checked out. So basically, I'm going to reanalyze the file here, redo a complete analysis of the project. What you'll notice is that it's going to take maybe like 1 minute to analyze about 100,000 files. I do believe we are quite competitive in that matter. I do believe we're probably the fastest static code analyzer I know out there, and I think it's because of the simplicity of what, how we deal with things. So analysis being done, we want to go check that our memory leak has been fixed. So the first thing we'll do, we'll go in CodeCheck. We open our CodeCheck. I'm going to hide those guys. I'm going to select again demo memory leak, right? On my demo Vulkan bug hunter. I'm going to inspect, and I do expect it to have 0 violation at this point because my memory leak was fixed. I actually did add the freeze that I needed. So great. As a developer, of course, I'm going to run again my MISRA just to make sure that I did not screw up anything. So I'm going to select MISRA C++23. I'm going to do my MISRA validation, my set of files that I want to run the MISRA validation, and I'm going to run this. So because I baseline it and I remove those 12,532 items, I should actually get 0 error here. So we'll give it a minute to run. Again, I think what you see here, I have removed maybe 3 checks that were like double check that were taking a little bit of time. So I was expecting 0, I get 5. That's surprising, but let's look at what happened here. Those are funny. Of course, this violation is, we can actually show them. Let's go to this violation. So see, dynamic memory should not be used, right? So we do have the fact that MISRA doesn't let you usually use free. So of course we get 2 violations here because we have done some free. So we have 2 checks that are actually saying, hey, dynamic memory should not be used. Free is one of the functions that's not allowed. So I guess that would be as expected. Now, the more interesting part is that it seems like this change, or this not this single change, because of course it was part of a sprint, but someone else have introduced some error here, which show me that it says that this function here is being actually called recursively. If you actually look, again, I'll just quickly do this. Oops. It's basically saying functions shall not call themselves. So of course, how am I going to do this? I can actually go and start looking at my call tree on draw, and I don't see draw calling draw, so I'll go 1 level up. I still don't see something calling draw, and then I go 1 level up, and then I'm really starting to get something quite complex where I may or may not be having an obvious view of what's going on. So there is a better way of doing this. Well, my first thing would be, okay, well, somebody changed something. So I'm going to look at my Git history and try to see what the change is, right? So, so I'm going to do a git diff. I do believe it's stat between demo v5 start and demo v5 fix2. So basically that is going to give me the statistic of what I've changed between the previous version that we had, where we had no error, and the current error where we have that recursive thing. Oops, obviously I did something wrong. And I do believe it's dash, if I'm correct. Yeah. So basically, those are the stat of everything that I've changed. So it seems like 415 files have changed, about 11,613 in session. So basically using Git here is going to be a little bit of a problem. So I know you guys can talk, but question is, right? What would you do? I mean, what's your next best guess about like the call tree is way too complex, it's way too many channels, stuff like that. So luckily, again, understand as a feature which lets you compare different projects, which is going to come really, really handy here. And I think some of you may have never ever heard about this. So if you look at the compare menu in Understand, you do have the idea of a comparison project. So a comparison project is, it's like comparing two of the project of the same code, right? You basically said, okay, well, like this is version 1, version 2, can you do a comparison? But there is a quick trick that you can do is you can create a comparison project on the current file, on the current project you have, but for a different tag or a different revision. So right now we are at demo v5 fix 2, right? This is where we are, right? We did the git checkout on that. But I'm going to say, okay, well, create me the same project that I have, except the file, use the one that were in demo v5 start. So it's going to do this. I'm going to create the project, and it's going to analyze it. So it's basically automatically creating a project at a different revision. And if you look at the file by itself, so if you look at the project again, you can see that Understand is creating another UND directory here, another file. So he has created a separate project that then is being used to compare, right? So it's created in the same directory. So right now, what you see when you're saying analysis is just like if I had opened the other project, analyze it, and now my comparison is ready. And that gives me access to tool I never had before. So remember, I need to try to look at draw here, and I need to see, okay, what have changed? What did create a problem? And in the compare here, I can locate change entity. So basically, Understand is going to create me a list of everything that have changed in the code. But not the source is creating by entity. So C is basically saying, oh, well, all those files have changed, but I can actually sort by function. And I say, okay, what are the functions that have changed? And now I can see these functions that have been changed. So see, there is a static function in vulkan.cpp that have been changed, and that's the one where we fix the leak, right? But the second meaningful function that was changed is here. There is a call to draw that were added in this file. So here you go, my culprit is here. This is the change that created my problem, right? So in 2 minutes, I was able to find it using the change entity. Another thing which is kind of like another alternative route by which we could have gone was that if I was going to go and take draw, and remember when we did the call tree, and we could not find, remember we had the classic call tree, which was, actually we had the simplified one, we had that call tree, and we tried to go this route. But look, now they have a compare call tree. And if I do, let's say level, okay, 3 level, let's just put that. And let me hide the thing here. But if you look at this, you can see draw have changed, because it's like highlighted, and then if I look in that code, I'm looking for other places where things have changed. Oh, look, setup swap change. See how it's becoming like it's thicker? So it actually shows me that this function have changed, and I can actually see the difference here, right? It shows me the difference. So this function has changed. And look, there is even this arrow here, which is green, and green means that it has been added, right? So I was able to, I can go get a graph like this, but I can see what have changed between version 1 and version 2 and what actually caused that specific problem. So this is called the comparison feature in Understand. It's actually quite super powerful. And when you mix it, especially if you have a Git repository with the ability to go and do Git checkout like that, and like different, put like revision or take a different tag and compare those two projects. It's actually quite a super powerful project, super powerful. So, all right, so So coming back to what we discussed, right? We talked about validation reporting. We saw CodeCheck, we can run MISRA, we can create our own configuration. We have looked at Bug Hunter, which helps you find more dynamic problem, potentially worth a run on your code. I've explained a little bit how Understand can help you gain the knowledge you need in terms of having the context, explanation, or documentation of the code when it doesn't exist. Spend some time explaining how you can control the execution in your code. You can look at things. There's control flow, butterflies, the virtual debugger, as I explained. The bug hunter as well, that gives you the traceback, right, of how the problem was created. Explain the data flow, how you can actually gain insight on the variable or what's creating it. How you can also be in control of, when you touch something, is it going to break something else? Well, that's done with dependencies, right? On the way up and on the way down. The change and the history. We have actually seen new technique, right? We can actually go and use these to compare and potentially find new issues or what did someone screw up, right? So those are actually the core functionality of Understand. But and again, we are looking for feedback on the AI generation, right, and the virtual debugger. But what I wanted to also point out today is that Understand is a fairly extensible tool, right? You guys are all probably knowledgeable about the fact that there's a Python API that lets you create graphs, script, everything. Even the report that we show, right, that compliance report, you can actually customize it. But Understand really can become a knowledge platform for so many things. And there is tools out there that are using Understand as a parser and then provide platform for technical debt and more how your code gets impacted, not only by the code, but maybe by who's the author of the code or the architecture, all those things. So there is a lot of different things that Understand is now able to provide. And one great source to look at is, again, another link, and I think you guys may not be familiar with this, but if you go to blog.scitools.com, again, earlier I showed you support.scitools.com, blog.scitools.com has a lot of articles about solving problem beyond just the code itself. And I want to show you two examples of this. And those are done through plugins. So plugin in Understand, you will see it's also something that's new in 7.1. If you are familiar with the plugin in Understand before, you used to just drag and drop files in Understand, Python file. You can still do the same, but there is plenty of plugins that are being created and are being introduced in Understand. And one of the interesting one is they have a Git solution. And same thing, those plugins, you can search them through the GUI, through a similar GUI from the CodeCheck that we have. But I just want to present you just an article that one of the developer I've worked on, which is the impact of especially if you have a Git repo and you have author and things like that. How Understand you can create different plugins to give you the author of a file or how a file relate to something. So I have enabled Git author here. I have enabled Git commit coupling. So for instance, Understand as those custom script now that let you, for instance, vulkan.cpp, right? I can run that interactive report, which is a GIF author, for instance, and it's basically just going into the Git database and formatting it into a report, which show you, okay, Chris Trasher has been the owner of that file because he's the one who created it and has done the maximum amount of commit on it. You can see the minor contributor from it. You can also, one of the one I like is you can see the coupling, right? The Git coupling will show you that, okay, every time this vulkan.cpp has been checked in, well, island.cpp has been checked in, right? But Understand give you a little bit more insight than that, because it also say, well, island.cpp has been checked in 39 times with vulkan.cpp, but if you look at the reference, right, what we talked about, how something depends on something, well, there is no reference at all between island.cpp and vulkan.cpp. So why would those will be checked in at the same time, right? Well, of course, if you go to this guy and you do a Git author, well, you'll realize that Chris Trasher is the main author of that file. This guy is the main one. So you can gain some sort of insight that even if those two files are not basically links, they're just basically being checked in because they are the same author. Or you can create interesting things. For instance, I really like this one, which is you have some of those plugins let you create custom architecture, right? Remember, architecture is a grouping of files, but I can go and I can say, okay, create me a GIF author. So I have created an architecture. All those files, I have put them under an architecture based on who created them, right? And what's interesting with this is you can marry that with a lot of the power of Understand. So one of the one I really like is you can go do a graph, dependency graph by GIF author now. So what that one does show you is there is file in there, there's file in there, and how many relationship basically, or how many of those files are dependent on files that this guy is the author for. So that gives you kind of a picture of the team here, where you can see who is working with somebody else. So for instance, Chris Trasher is working with Ricardo, right? Obviously those guys must communicate because they have a two-way dependencies here. Same thing for this guy, right? And you can see Chris Trasher looks like he's in the middle of the grouping. So it has like a fairly good, this is definitely the central guy in your team, right? So you can gain insight like that with Understand, which yes, Git will allow you to group things by author, but you will never be able to generate a diagram like that where you also have how the work of someone depend on the work of somebody else. Similarly, we have people that come and ask us for, hey, my code is so complex, I don't understand how it's structured. Well, again, if you go to blog.scitools, you'll find that article from Harvard that explain a little bit on how you can organize code based on how files depend on files. So the idea is if you take a piece of code, you can grade that code with a VFI number and a VFO number. A VFO number will be basically simplified as how many files are dependent on me. A VFI is how many files depend on me. And then if you try to group a source code in 4 different blocks, which is core, periphery, control, and shared, based on if they have a high VFI or a low VFO. So basically the core of your software will be the one that have a lot of people depending on it, and a lot of people and you are depending on a lot of people. That's your core. Your periphery is whoever is not really dependent by anybody or doesn't depend much on everything. So they are just those files that live on themselves. The control are the one on the top of the tree, right? They depend on a lot of people, but they don't depend on many people. And the shared are at the bottom of the tree. So Understand lets you run a little Python script that actually run that analysis. And it's really interesting when you actually run it on this project, because again, same thing, I can create the visibility matrix. And then it's going to create that hierarchical with central, control, periphery. And when you do a graph, dependency graph by visibility matrix, you will actually notice that Understand is exactly doing this, right? The control is depend on everybody else. So central depend on, is dependent by people and depend on people, and periphery is lightweight number of dependencies, right? But these validate your project is well architecture if you actually go and do the metrics, right? This time I do that with my visibility matrix. So see, I can see my control, my shared, my central, and my periphery. There's just one big file here, which is problematic. But if you actually leave those 4 groups are actually well balanced, so that shows me that it's a fairly healthy project in terms of architecture. Again, you may want to read that article. It's really interesting. All this is on blog.scitools.com, but know that there is many extensions you can use to create things to Understand. So again, look, I'm going to take time to answer the question, but I want to finish with this. If you have question trials, if you want the recording, if you want more details on anything, please feel free to reach out. So we have a team in the US. It's us.sales@emanda.com. If you want to reach me directly, stefan.reno@emanda.com. I think most of you have received an email from me for the invitation. Or you can also send stefan@scitools.com. So think of it as Stephanie@scitools.com and remove the I, and you'll see me. If you are in France, in China, or in other place, you also have different address that will be in order to get evaluation or answer any questions that you have. I actually do look like this guy as well, if you ever met me. So anyway, thank you very much for today. I hope that shows a lot of the new feature in Understand 7.1. I will take question one after the other, and I will reply to this. But if you need to go now, I understand we are on top of the hour, and I thank you very much for your time here, especially before the big weekend. So happy 4th of July, and we'll talk soon, I hope so.